In this video, we're going to be worrying about solving equations. First of all, what is an equation? You might have seen them before. Equations are things that look like this, and what makes an equation is got an equal sign. And it's got something on the left of that equal sign, and it's got something on the right of that equal sign. And the equal sign is sort of the important part here. It tells us what's over here has to equal what's over here. So basically what it's telling us is that this part has to equal 5, right? Because this side equals 5. So if we're trying to solve an equation, we're trying to find a value of x. So x might be 1, it might be 2, it might be -1, it might be -2. Some value of x that's going to make the left side equal to 5. Right? So you might be able to see the answer right now just by sort of thinking about it. But another way to look at it is a balance, like a balance scale or a teeter-totter. And the equal sign is sort of your balance point, right? And what this tells us is that the left side and the right side have to balance each other, right? Always. That's what the equal sign tells us, that they always have to balance. So here we would have like 3x and we have a 2. And here we have a 5. And these two things have to balance each other. So we're allowed to manipulate equations a little bit. So for example, I could add some weight to the right side. Let's say I add 2 more to the right side, right? I add 2 more to the right side. Now, this thing isn't going to balance anymore. It's going to want to move to the right. It's going to want to, like this is going to want to go down, right? Because it's heavier. So in order to keep it balanced, what should we do to the left side? Well, we also have to add 2, right? So basically what we've done is we've created a new equation where this is going to be 3x plus, well, 2 plus 2 is 4. And on this side, 5 plus 2 is 7. So we've created a new equation that also balances, right? That looks a little bit different than our original one. But the important thing is that we know that the equal sign is still true. What on the left side and the right side are still equal to each other. We could do the same thing if we wanted to like subtract 10. Let's say we wanted to subtract 10 from the left side. What would we from the right side. What would we have to do to the left side to keep it balanced? Well, we'd also have to subtract 10 from the left side. So if we got that, what would our new equation be? 7 minus 10 is -3. And if we had this 4 here and we're going to subtract 10 from it, it's going to take us to -6. So we'd end up with 3x minus 6 equals -3, right? So this is another version of that same equation that is also balanced. So all 3 of these things are true, right? So the point is, we can manipulate equations by doing the same thing to both sides. How does that help us find out what the value of x is? And that's what we're going to look at in the examples below. So let's look at the first one. X plus 10 equals 8. What are we trying to do there? We want to know what value of x will give us an answer of 8 on the right side. So like if we try to plug in x as 1, for example. 1 plus 10 is 11. That doesn't work. Try to do x as 2. 2 plus 10 is 12. That doesn't work, right? -1. -1 plus 10 is 9. So that's getting closer. So you could sort of go through and try to figure out what the answer is. But what I'm going to do is I'm going to show you a process which will always get you the right answer. And it makes it a little bit easier so you don't have to rack your brains trying to think about how to do it. So this is the thing. Remember we talked about we can manipulate the equations by adding and subtracting things from both sides? Well, yeah, we can do that here too. And the key is we want to isolate x. We want to get the variable by itself. That is the important thing. We want to isolate the variable. So in order to isolate the variable, to get x by itself, we want to get rid of this 10, this positive 10. How do you get rid of a positive 10? Another way of asking this is, what's the opposite of plus 10? And the answer to the opposite of plus 10 is minus 10, right? So in order to get rid of that 10, we can subtract 10. Because if I subtract 10, 10 minus 10 is 0, so this part goes away. But remember, the equal sign means it's a balance. So whatever we do to the left side, we have to do to the right side too to keep it balanced. So we also have to subtract 10 over here, right? We have to do the same thing to both sides. So on the left side, I'm going to put the equal sign right underneath. It's actually sometimes easier to draw a line down the middle because the left side and the right side are separate from each other, so you might want to do that. So on the left side, we've gotten rid of this, so all we're left with is x, right? And on the right side, we have 8 minus 10. And what's 8 minus 10? It's negative 2. So that's our answer. X is negative 2. Negative 2 should have made this equation true. And we can check it. If we do negative 2 plus 10, what does that give us? Well, it gives us 8. So we're good. We got the right answer, right? Negative 2 is the answer to this equation. So the key here was using opposite operations. To get rid of the plus 10, we did minus 10. So that tells us the opposite of adding, what's the opposite of adding? Well, it's subtracting. What do you think the opposite of multiplication is? Division. So these opposite operations help us to isolate the variable. Okay, I'm going to do one more example, and then you're going to try. So 6 equals x minus 5. Some value of x there is going to make this equation true. It's going to make the right side equal to 6 as well. So we have to ask ourselves, how do we get x by itself? We have to get rid of that minus 5. What's the opposite of minus 5? Plus 5, right? So I'm going to draw my line down the equal sign. I'm going to put another equal sign down here. And we're going to do x minus 5. The opposite of minus 5 is plus 5. So we have to add 5 to get rid of that 5. But then we also have to add 5 to this side. So what's 6 plus 5? It's just 11. So there's the answer. 11 is equal to x. Or another way to put it, if you want to flip it around, x equals 11. That's our final answer. Okay? We put a box around it. It's always a good idea to identify your answer by putting a box around it or circling it, just to make it super obvious. Okay? So that's the answer. I want you to try these two questions, the next two questions yourself. Okay? Pause the video here. Try it. Unpause when you're done. So here are the answers to those questions. Notice how in this one we were trying to get rid of the 4. So to do that, we subtracted 4. And we had to do that to both sides too. And what that did is that actually it canceled these out, so they're gone. And we end up with x equals minus 14, or negative 14. Okay, that's our answer there. And in the second one here, we needed to get rid of that minus 3. So we added 3 to both sides. So x is equal to 13. Or, 13 is equal to x, or x is equal to 13. Okay, and what that did is that got rid of that 3. Okay? So what I want you to try now is the questions below. Try these 6 questions yourself. Pause the video here, try them yourself. Check your answers. They're on the next page. And when you're done, you can unpause and go on to the next section. Okay, it's very important you try these questions before moving on. So pause it here, try them, and then we'll move on. So actually, before moving on, what I've done is I've put down the operation that you need to do to both sides to help you solve the problem. So this question, in order to get rid of this 5, we needed to subtract 5 from both sides. This question, in order to get rid of this 3 here, this is a little bit tricky because it's not, the x comes second, but it doesn't matter. In order to get rid of a 3 that's positive, we know it's positive because there's no negative sign in front of it, we have to subtract 3. So you just need to subtract 3 from both sides. This one you needed to subtract 5 from both sides to get rid of that 5. This one we need to add 2 to get rid of that 2, that negative 2. This one we need to add 3 to get rid of that minus 3. This one we need to subtract 5 to get rid of that 5. Okay, so you can do those yourself, check your answers, and we'll move on. So now we get to some questions that are sort of similar, but they're a little bit different. So 3x equals 15. Which value of x is going to make that equation true, is going to make this side equal 15? Well, you can probably see what the answer is right away, but using our balancing method, let's think about it. What's happening to x? Well, when there's two numbers beside each other, or two things beside each other in math, without anything in between, we always assume they're being multiplied. So this is like saying 3 times x, right? So if this is 3 times x, how do we get rid of that 3? Well, what's the opposite of multiplying by 3? dividing by 3, right? Division and multiplication are opposites. So what we can do to get rid of that 3 is we can actually divide by 3 to get rid of that 3. But then what do we have to do to the right side? We also have to divide by 3. Remember, we got to do whatever we do to one side of the equation, we got to do the other side because we got to keep it balanced. So x is just equal to, what's 15 divided by 3? It's 5, right? So we got our answer. And you could always, again, you could always double check. 3 times 5 equals 15. You're good. Okay, let's do the next one. X is being divided by 4 in this one. Remember, that's what a fraction means, right? So something divided by 4 is going to give us 10. But x is being divided by 4. So what's the opposite of dividing by 4? Multiplying by 4. So when we multiply by 4, we're going to cancel out those two 4s. And we can't just multiply 4 on one side. We also have to multiply by 4 on the other side. So 10 times 4 is 40. So the answer is x equals 40. And that makes sense because if you plug that back into the original question, 40 divided by 4 is 10. So we're good. We have the right answer. And just last thing, I'm gonna put circles around my final answers to make it clear. Okay? So I want you to try those next two questions, the your turn questions. Pause the video here, try them yourself, unpause when you're done. So here we go. Here are the answers. For the first one, we needed to get rid of the 7 by dividing by 7. And 21 divided by 7 is 3. For this one, we needed to get rid of the divided by 2, so we had to multiply by 2. So on the left side, 2 times negative 12 gives us negative 24, so the answer was negative 24. Okay? So now it's your turn to try the rest of these questions, okay? The answers are at the bottom of the page. So pause the video here, try them all, and when you unpause, I'll give you a few little hints if you're stuck. Okay? Try them. So just so you know what the operation is that we did in each question, here, the operation to get rid of this 2 was to divide by 2. So you had to do that to both sides. For this one you have to be a little bit careful. We want to get rid of the negative 5. And the negative 5 is being multiplied by x. So what's the opposite of multiplying by negative 5? Dividing by negative 5. So you should have divided both sides by negative 5. This one, x is being divided by 8. What's the opposite of dividing by 8? Multiplying by 8. This one, a little bit tricky here. X is being divided by negative 4. What's the opposite of dividing by negative 4? Multiplying by negative 4. This one, x is being divided by negative 1. What's the opposite of dividing by negative 1? Multiplying by negative 1. That's why the answer here is just negative 10, because 10 times negative 1 is negative 10. And lastly, this one we needed to divide by 10 to get the answer. There you go. So what you have now is you have some more problems here. Try it yourself. This is like mixed between addition, subtraction, multiplication, and division problems. So try them yourself. The answers are at the bottom of the page. Okay? Go for it.